All right, so now we're talking simplifying roots of negative numbers, right? In the past, without the use of I, or complex numbers, we could never take the square root of a negative number. But now we can. All right, so now our task is to simplify this. A simpler example than is on the screen is right here. Let's say I asked you to take the square root of negative 9. We would notice that within that square root, there's actually two things going on. There's the square root of 9, but there's also the square root of negative 1 in there. The square root of 9 is 3, and what we just learned in the powers of I is that the square root of negative 1 is just plain old I. So this would simplify to just 3I, and we'd be done, right? And that was easy because 9 had a square root, right? 35 does not have a square root. So what we need to do is check to see, are there any square roots that live within 35? So here's what we're looking for. Do any of these numbers, which do have square roots, do any of these go into 35? I want to stop here because the next perfect square is 36. That's too big. So then I ask myself, does 4 go into 35? Does 9, 16, or 25? Well, the answer is no. And if the answer is that there are no perfect squares within a number, then we would simply answer it this way, that our answer is the square root of 35, I. Much like it looks here, the only difference is we can't simplify the square root of 35. So if we click in the box, we can see that the square root is there. Make sure when you type I, you leave a little space in between, or hit the over button. The I should not be under the square root. All right, let's do another one. Square root of negative 16 is the same thing as the square root of 16 times the square root of negative 1, which is 4I. Easy enough, right? Okay, let's try another assignment here since we're on this. Let's go over to the parts of complex numbers. So the next assignment should be something like this: parts of complex numbers, or classifying complex numbers. Super easy assignments, but let me just run through them really quickly for you. There are two parts to every complex number. There's a real part and an imaginary part. The real part is the number by itself. So this is negative 172. The imaginary part is the number alongside I, which I would say 8. I don't want to answer just 8I. Okay, I just want to say 8. Another example, what are the real and imaginary parts of Z? The real part is 77. The imaginary part is negative 27.8. Not with the I, though. I almost answered it wrong. Okay, there we go. That's the parts of complex numbers. Last assignment I want to look at is classifying complex numbers. There are three different ways we can classify them. They're either purely real, imaginary, or complex. Okay, so here we go. Is this number imaginary, real, or complex? Well, obviously we see the I, so it must be imaginary. But if we notice, choose all answers that apply. See, here's what's happening. There's the real numbers that are here. There's the imaginary numbers, which live in a separate world. But they both live in a huge, enormous space of complex numbers. That's what's going on. So every imaginary number is also a complex number. Every real number is also a complex number. What we notice is this has a real part. It has an imaginary part. So we can't say that it's just real. We can't say that it's just imaginary. It's complex. Last one, we notice this is just a number. There's no imaginary part to it. However, we remember that every real number lives within the huge, enormous world of complex numbers. So in this assignment, you should always select complex.